In today's video, we're going to be approximating square roots, aka radicals. So the square root is the function that is opposite of squaring a number, basically the opposite of multiplying a number by itself. Now, when we're approximating square roots, we need to memorize the list of perfect squares. These are numbers that when you take the square root of them, they end up being a whole number solution or a whole number. When you simplify them, it's a whole number answer. So the list of perfect squares is basically, if you know your times tables, okay, the list of perfect squares, right? 0 squared, which is 0. 1 squared, 1 times 1, which is 1. 2 squared, 2 times 2, 4. 3 squared, 3 times 3, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. And 12 squared, 144. So these are the list of perfect squares, right? Up to 12. So what we're going to be doing is approximating these and see where they are located on a number line and what integers they are in between. So let's take a look at the first problem. All right, it says between which two consecutive integers the square root of 40, radical 40, lie? Okay, so 40, we take a look back at our perfect squares. 40 is in between, right here, 36 and 49. That's where 40 is in between. So when I go over here and I label a number line, we know it's in between the square root of 36 and it's in between the square root of 49. Now, what is the square root of 36? The square root of 36 is 6. The square root of 49 is 7. So it actually lies in between the integers 6 and 7. Now, it's probably 40 is closer to 36 than it is 49. So 40 is probably going to be somewhere in here, closer to 36 than it is to 49. So maybe like 6.4 or 6.3. All right. And our reasoning we're going to explain is since the square root of 36 equals 6 and the square root of 49 equals 7. That's going to be our reasoning. Okay, let's take a look at the next one. Square root of 111. Where does that lie in between? Okay, 111, okay, right in between 100 and 121. So when I graph this, it's going to be between square root of 100 and the square root of 121, which is square root of 100 is 10, square root of 121 is 11. So it's probably, it's going to be a little bit tiny bit closer to 121, right? So it's going to be like halfway, a little bit here. That's where the square root of 111 is in between. So it's in between the integers 10 and 11. These two numbers. Okay, and our reasoning, since the square root of 100 equals 10 and the square root of 121 equals 11. So it's going to be probably 11.5, 10.5, 10 points, probably closer to 10.5 than 10.6. Oh, let's see what happens when we have a negative. Now, be careful with the negative because on the number line, well, first of all, let's find where 33 is in between. 33, where are we at? Over here. 33 is in between here, 25 and 36. But careful with the negatives because the smaller negative is 36, not 25. because negatives on the number line look a little different than positive numbers. So it's going to be between negative square root of 36 and the negative square root of 25. Negative square root of 36 is negative 6. Negative square root of 25 is negative 5. So it's going to be in between. 33 is closer to 36 than is 25. So it's probably going to be somewhere here. Okay. And that is where my negative radical 33 is. It's going to be between negative 6 and negative 5. Since the negative square root of 36 equals negative 6, and the negative square root of 25 equals negative 5. Okay. So it's always good to kind of explain where you got these, but the key thing is to memorize this list right here. The perfect squares 0, 1, 4, 9, 16. It's always good to write those out and have those in front of you whenever you're dealing with radicals or square roots or any kind of roots. So it's important to know that. So make sure you memorize this list. All right. So that's it for today's video. Thank you for watching. And always remember, whether you're solving for X or Y, always give math a try.